Okay, so now a comparison of all the feedback types. So we have 4 feedback types: current series, voltage series, current shunt, and voltage shunt. And we are finding all the parameters. See, voltage gain, it is uniform because whenever you are going to apply, voltage gain will be always decreasing. This is going to be same. And bandwidth also, you see, whenever voltage gain is reducing, bandwidth will increase because I told you gain bandwidth product for any amplifier, it is going to be constant. So whenever you're considering any amplifier, when you multiply gain and bandwidth, it will always be constant. That's why when gain is decreasing, bandwidth will increase, so that this product is always a constant. This non-linear distortion will decrease always for any feedback. The distortion will decrease for any feedback. The noise will decrease. So these 4 parameters are same. So you need not by heart. See the table, all are decreasing for voltage gain, all are increasing for bandwidth, all are decreasing for nonlinear distortion, and all are decreasing for noise. See, these are logically, you know, when you are going to apply negative feedback, gain will decrease, bandwidth will increase, noise will decrease, distortion will decrease. Now see here, how to write input resistance and output resistance. Whenever you see a term series, this is current mean this represents output. See, always in this notation, first term is output. First term is output, second term is output. Okay, whenever you have a series at the input side, resistance in series, so resistance will increase. See here, series increase, shunt decrease, shunt decrease. For input resistance, see the term corresponding to input. You have current series. In this notation, the current represents the output side, series represents the input side. Resistance will increase in series. So whenever you have series connection at the series mixing at the input side, resistance will increase. Whenever you have shunt mixing at the input side, the resistance will decrease. Is this logic clear for everyone? How to write input resistance from the name? Now output resistance. See here, output side current. You know, current will be same in series. In series, resistance will increase. So increase. Same way, current will be same in series. In series, resistance will increase. So increase. Voltage will be same in shunt. In shunt, resistance will decrease. So decrease. Same here in voltage. I am taking voltage from the output. Voltage will be same in shunt. And when you connect different resistance and shunt, the output resistance will decrease. So this is how you write the expression for input resistance, output resistance without mugging up. Just you need to see the terms and write whether the input resistance will increase. There is only 2 options. Either it should be increasing or it should be decreasing. You cannot have an option like neither increasing nor decreasing. No, definitely when you are going to apply one among the 4 feedbacks, definitely when input resistance may increase or decrease, the output resistance may increase or depending on the configuration. That only we are writing it from the name. So it is very simple. You need not remember what is an amplifier, what is a current series amplifier to comment about the input and output resistance. That is not required. From the name, you can easily say what is at the input side, what is at the output side, and how the resistance is going to vary in both of the cases. So any doubt in this table and the voltage and feedback, whatever we have studied, if you have any doubts, you can ask now. I have told you all possible shortcuts. We'll pause for a few seconds, and any doubt, please unmute yourself and ask without getting your doubts clarified. There is no point in continuing our learning. If you remember this table, it's going to be very, very easy for you.